In this video, I'd like to look at finding the area of equilateral triangles, and there are a couple of ways to do this, okay? One way is to use the basic half the base times the height formula, okay? Remember that equilateral triangles have all 60-degree angles, and of course we know the base is 10, that's not a big deal. The altitude is going to go from the vertex down to the base. For an equilateral triangle, it'll divide it into two congruent triangles, and notice, right triangle and a 60-degree angle, that angle up there is getting bisected. That's a little 30, 60, 90 triangle, okay? So as a result, this side is 5, right? 5 and 5 adds up to equal 10. It's 5, 10, multiply by radical 3, and you get your altitude, okay? So you can take half the base times the height, okay? That'd be 50 radical 3, you're taking half of that. 25 radical 3 square units would be the area of that equilateral triangle, all right? Process works the same pretty much every time. It's not a terrible approach, works out very nicely. However, you can make a formula that will generate an area just a little bit faster, okay? Remember that the area of that was 25 radical 3. We're going to come back to that in just a minute, okay? I'm going to come back and I'm going to do this with variables, okay? And I'm going to see if I can write a formula, okay? So the area of a triangle is still half the base times the height. But instead of making the side 10, I'm going to make the side lengths s, okay? Just a variable representing any possible side length. This is still a 30, 60, 90 triangle. So this side here is still half of that triangle there, okay? It's going to be 1/2 s, okay? You still multiply this side by radical 3 to get that side, okay? That would be 1/2 s times radical 3. It's all being multiplied, so I would multiply the 1/2 and the radical 3 together. That's radical 3 over 1, and get radical 3 over 2. I'd probably write that as s radical 3 over 2, something like that, okay? How do you find the area of a triangle? Well, you take half the base and you multiply it by the height, okay? So I'm just going to put the variables in my formula, and it should work out and give me some kind of a formula for the area of the triangle. So it's 1/2 the base, which is s, times the height, which is s radical 3 over 2. You know what? I'm actually going to break this up again. I'm going to write this as s times radical 3 over 2 times 1/2, okay? And if we put all this together, notice what we end up with here. S times s is s squared. 1/2 times radical 3 over 2. 1 times radical 3 is radical 3. And it's going to be over 4, okay? Now, your book is going to rearrange this just a little bit. They're going to say it's 1/4 of s squared and then multiplied by radical 3, but it's all the same difference, okay? So your book's formula for the area of an equilateral triangle is that it's s squared over 4 times radical 3, okay? It's not 100% required, but it is a pretty convenient formula. Okay, now remember the example I did a minute ago. I had side lengths of 10. Well, according to the formula, 10 squared would be 100, right? Side squared, divided by 4 times radical 3. Well, 100 divided by 4 is 25, okay? So the area is 25 radical 3 square units, okay? If the side lengths are 8 squared would be 64, divided by 4, times radical 3. 64 divided by 4 is 16, okay? So an 8 by 8 by 8 equilateral triangle would have an area of 16 radical 3 square units, okay? One of the other things that's really nice when you're working with this is it also is going to give you the ability to work backwards. So for example, if they tell you that you have a triangle that has an equilateral triangle, remember it's got to be equilateral, it can't just be any triangle. But let's say that the area is 9 radical 3, and they want you to figure out what the side lengths are, okay? All you've got to do is take that s squared over 4 radical 3 formula and set it equal to 9 radical 3, okay? And if you think about it, they both have a radical 3. So I'm really just trying to get 9 to match up with s squared over 4. In fact, you can divide this side by radical 3. You can divide that side by radical 3. That'll knock out the radical 3's on both sides, okay? And then you have a little equation you can solve here. Multiply by 4, you get side squared is equal to 36. What do you square to get 36? The side length would be 6 units. So So a 6 by 6 equilateral triangle would have an area of 9 radical 3. So again, not the most important formula in this chapter, but it's one that will be helpful from time to time, okay? I would highly encourage you to know this. The area of an equilateral triangle is the square of the side divided by 4 times radical